Okay, so this is a recording for chapter 6. Um, in the book, we're going to be talking about data and databases. All right, so we talked about it as we were going over this whole the nature of information technology and infrastructure and systems. One of the things that have come up, one of the key elements is this idea of data and information. All right, so the idea is that if you remember the pyramid we had talked about before, information data is the lowest levels. It measures collections of different types of measures that are recorded and can be analyzed. All right, through applying context, calculation, any number of different approaches. All right, so and ultimately the objective is to take data and turn data into information. Information is what people use, what organizations use to drive decision making. So as we say here, information is power. The idea is you want to be able to get information, and that the process by which we go through this is basically a lot of the stuff in organizations is driven through kind of those enterprise applications we talked about. So ERP systems and CRM systems and SCM systems and other types of information that are being generated on um, being generated out of transaction systems are all the sources we would look at for this. So it's not limited to that, but that's actually a pretty big source in modern businesses. They're kind of the enterprise applications as a source of data. All right. But one of the challenges, especially with the what organizations discovered, was transactional systems are specifically designed to do business transactions. All right. So the idea is that the data is structured in such a way so that you can execute a transaction very quickly. All right. What it does not do, it does not really provide the ability to go back and to analyze large chunks of data and be able to kind of look at it and you know process it, be able to make develop information that you could be analyzed and reviewed. All right. So what actually happens is there's we look at the ERP systems, the transactional systems, that is all transactional, pretty granular data. And to really turn that data into information, we're really looking for kind of analytical. And so there's analytical tools. These are the types of data, or excuse me, information that we would generate from the data. So the idea is that there's one database or one set of databases that are kind of sit at the bottom, at the core of the organization in the ERP systems, being updated on an ongoing basis through transactional information. And then what happens is, to do an analysis, we'll go back and pull that information and then manipulate it, adjust it, review it, process it to be able to convert that data into information. All right, so the idea is we're doing multiple things we do: collection, compiling, sorting, analyzing information, data, different formats, different granularities, different types of data from different sources. Um, the things we look at, though, the value of it, one of the challenges for organization is there's a couple different um, areas that you need to be good at or be able to focus on. One is, being able to number one, be able to differentiate between transactional information and analytical information. So the idea of being able to capture data through the result of your execution of your business processes and then analyzing and taking that information and then analyzing it and then kind of make the structured, semi-structured decision making. The other thing, another key attribute is what we call timeliness. The idea is you want to get the timeliness of the data is really a function of the business. How quickly do you need it? A lot of organizations think, well, you need, faster is always better, which is not necessarily the case. All right, so there are circumstances where fast is the right choice or the right path you want to follow. However, that's not a hard and fast rule for all things. You really what happens is you want to be able to align the information timeliness with the needs of the business. All right. Sometimes if you get information coming in too fast, organization can't process it, or it's unable to process it, which is almost as bad as not having good information, overwhelming people with the information. Another attribute of information is quality. The idea is, not only is do you have you know, the timeliness of the information, you're pulling it, but making sure that it's correct, that it's of high quality. So the quality of data is a real challenge in a lot of organizations, trying to identify data and making it as high quality as possible. There's actually there's a cost associated with that, and a lot of times what you need to do is kind of you know evaluate what is the quality. At what point does the quality become good enough to be able to make good decisions? So which is less than 100%. And then finally, governance. This idea of governance, which is the overall management of the availability, usability, integrity, and security of data. Um, One of the kind of a byproduct of the ERP implementations was I think there was a much greater awareness of the importance of data, and that data as an asset, and data as, more importantly, data as a business asset. Because a lot of times what had happened in the past was data, since it was in a computer, processed inside of a computer, it was the perception was that it was an information technology thing. It was the IT department's responsibility. The reality is it's a business decision, or it's a business asset, and that this idea of information governance is really the processes, procedures uh, that are put into place to make sure that you have, you know, good information, accurate information, timely information, all being delivered to the organization to support decision making. So as we talked about this a little bit, these are the attributes, the key attributes, the accuracy, completeness, consistency, timeliness, and uniqueness. All right. So some of the this is some of the stuff. This is might seem intuitive, but it's something that when you're actually trying to working on the governance of these things, make achieving all of these things and being able to evaluate and measure this stuff is a lot harder than it looks. A lot of times, like for example, with completeness, there'll be some situations where you'll get most of the data, but then there'll be gaps, and the question is, what do you do about the gaps? Are the gaps important? Do you fill them? Can you identify and construct data from other things that can be used to fill the gaps? Um, Consistency. One of the things you see, especially with transactional data, is it's very granular. All right, so we're capturing individual events, but when we process it, when we analyze it, as we're looking to evaluate it, one of the things we end up doing is we consolidate it. So, you don't want to necessarily get a list of everything occurring on a minute by minute basis. You want to see what happened in the course of an hour or a day or a week. So the idea is you'll aggregate. You'll hear this term a lot within, kind of this area where we talk about the aggregation of data. So, it's, you know, depending upon the circumstance, sometimes you want to look at the details, sometimes you want to look at an aggregate. But the thing you want to make sure is that the aggregate data and the detailed information add up, that one is consistent with the other. All right. There's nothing worse than, having a list of, individual measures and then an aggregate and discover that the two of them, when you match the two of them up, they don't match. That's not good. Also, the uniqueness. What we want to make sure is that, each event reflects an individual measurement or an individual collection of data. Each transaction event is represented only once, because that's really it. It's there'll be there'll be lots and lots and lots of similar or identical events occurring, but each one has its own unique identity. Okay, so the storage of a database. So the storage of this data. How do we store it? In modern organizations, we use something called a relational database, right, and a database management system. All right, so the relational database is this really kind of came into play in the early 1980s. It's adapted from relational algebra, which is deals with sets. So the idea is the way that a relational database is structured. There are sets of tables which can be basically set up and related to each other using keys in such a fashion so that if you can query, join all these tables together and get a result back. All right. So the idea of this relational model, which has really been around, which really has been the predominant data storage. So we looked at our SAP system. We did our order entry execution processing against that has a very large relational database at the heart, on over 100,000 tables. All right. Not every application is 100,000 tables, but so it represents things like customers and orders and products, distributors, um, returns, all sorts of different kinds of things that it need to be captured. Now, the DBMS is actually software. So the database is measurements or stored measurements, stored data, stored information. So this is a storage thing. The DBMS, the database management system, is a software thing. All right, and basically what it lets you do is provides access to the database. All right, to enter data, to create tables, to run queries, to do everything you need to do is all done through a DBMS, database management system. All right. And some examples: Oracle, Oracle BD has a they are probably the first early commercial relational database system. So they'll have a DBMS. IBM makes something called DB2. Microsoft makes something called SQL Server, which is actually an enterprise database. We will be using a Microsoft product called Access, which is a smaller desktop type of system. All right. So the thing you want to remember here is, this idea of, relational database being made up of tables, and a database management system is kind of the access, the thing that people, interface with. You interface with the DBMS, and the DBMS does interacts with the database on your behalf and returns the information. So some of the advantages, this stuff is once again kind of a motherhood and apple pie, but but they are true, and actually, um, you know, that's why it has become the relational database systems have really become the kind of the core technology that run most business applications. All right, so this idea of flexibility, um, information security, integrity. The thing about a database, the thing you want to remember about databases are all about rules. All right, so and that kind of makes them different from things like spreadsheets. So it'll kind of look like when you first look at us, especially when we look at Access, since it's a Microsoft product, it actually will kind of look a little bit like Access. It will look a little bit like Excel, but it is a different animal. All right, and the idea is the relational database defines a set of rules that basically allow for flexible access. It provides for information security and integrity. The ability to be able to performance. And reduced redundancy of data. All right, which ultimately the goal and objective of what you want to have is correct data. You want to make sure that the information that you derive from the data that's stored in the database is accurate and correct. And the relational model, if assuming that you define the rules the right way and you set the data up, um, the relational model is designed so that when you ask a question, the result you get back is correct. Now, most modern applications, this is what we see here is kind of a architecture of what most applications are constructed these days, especially stuff that are web-based applications. The idea is that what you have is a an application that's running on the web server, all right, presenting a web page, which is then submitted. Web pages, you know, submitted to the server. The server will go and perform a query. The application server, the web server, will query the database, basically ask a question, get a set of results back, and then process it, structure it, format it, and deliver it as a web page. All right. So this is pretty much, this is the structure. This is what Amazon is. This is what eBay is. This is what virtually any kind of web application these days. The first generation of web servers, if you remember, web-based applications, it was content only. All right, so you would have a page of data, um, which is useful, but where you really get useful is where you can um, bring back data dynamically. So the idea is what you have with this kind of structure here is the the data is actually stored in the database. You can do a query of different, to be able to pull different types of data out of the system and then bring it back. So one of the things about these modern applications are that there's actually a two-way um, kind of a two-way communication going on. So obviously, there's from the customer perspective, the customer is engaging through the website to be able to gather, basically to you know submit an order for something. All right, but what's happening is a from a organization, a company's perspective, that information coming in, there's information that is can be derived from the website, which can be captured and analyzed and processed to give more insights insofar as business activity. So the idea is that every click on a screen um, can be captured. So so you can go back and analyze, go back and kind of replay what a person was doing on the website from the information that's captured and sent down into the server. So what you'll see is a lot of times is information, especially like Amazon is very famous for this. Is what they'll do is they'll take a as a first step when you send a request into Amazon. What it will do is it'll kind of go through the HTTP message that goes into the web server. First thing it'll do is it'll go through and kind of pull all of the information out of it, kind of what your activity was. What did you click? Where did how long were you on the screen? How long, what are the things you looked at? What was it really? How do you kind of be able to play back what you did, and the idea of being able to analyze it to determine what your behavior is, and then kind of evaluate, the effectiveness of the web page. So you've got kind of this collection of data. It's not simply just the sale we're recording. We're recording a lot of other information, which becomes very important because it allows an organization to go back and really kind of gain more insights into kind of what people are, how people are using the site, and kind of be able to fine tune the effectiveness of it. So I think there's always been this question of data rich and information for poor. If anything, we've actually gone even more so um, over the past couple of years. The idea of there's always more data, and the golden objective is to be able to take all the data you're collecting and be able to analyze it and gain insights from it and be able to make decisions off of those insights. Um, One of the things about the ERP systems and those enterprise applications is it actually applied a level of discipline around data capture. Whereas before, there was a lot of data that was, you know, being dealt with in a process that was never really being captured. So, but the challenge of an ERP system is that it requires very precise execution in order to and the data, it needs certain data needs to be captured as you go through. So as much as people might think it might be a bit of a pain in the neck, it actually does enforce a layer of discipline around your data. And that became a big source of analysis. But now what we're seeing is this idea of unstructured data. So the data that's in the ERP system is it's in a database, highly structured both with rules and how it's organized, and it's very well defined. Unstructured data um, is still data, but it is not necessarily as readily usable, or at least machine processable. So things like voicemail and phone calls, text messages, video clips. So these are all data sources, unstructured data sources. And the big challenge, with organizations is being able to bring all of these things together and be able to analyze them, even though it's unstructured. There's still approaches and techniques that can be done to be able to analyze data and turn it into information. All right, but probably most organizations, if you go to if you talk to people, they will always say they don't have enough information. There's never, you know, there's never going to be a point where people are saying, okay, I have too much information. Well, you're always going to have another question, or see things a different way, or a different perspective, or a different, alignment of things. All right. So we've collected a lot of data in these ERP systems and CRM systems, but the unstructured data is really where when we talk about the volumes and volumes and volumes of data, that's the unstructured stuff is really the thing that drives a lot of that. All right. So the idea is you want to use kind of business intelligence. The idea of being able to use business intelligence tools to kind of process data of different types, both the structured data that's in databases, the unstructured data, be able to process it, and then be able to deliver the types of information that will drive better decision making. All right. It's a constant struggle, because just when you think is always a great quote. Just when you come up with the answers, they change all the questions, and that's really the case with a lot of this stuff. It's the rate of data, the volume of data. Um, we can capture more stuff than we've ever been able to do before, but then the demand just to be able to do more and more is really a reality of what most organizations are dealing with. So this idea of a data warehouse was a tool that was a tool maybe about 20 years ago, about the late 90s. And actually, it followed the ERP deployments, because what happened was the ERP deployments. In the ERP deployments, we did a lot of work in setting up those databases, those highly structured databases, to run those transaction systems. But what happened is immediately afterwards, okay, well, what we want to see the data, and we want to be able to get information out of these systems. And what basically happened was the transactional systems are designed to run transactions. They're not designed to run analysis. So it's how data is stored. So relational databases, yeah, you can use them to do analytics, but they're not necessarily the best in terms of performance and in terms of efficiency. More importantly, the transaction systems are busy doing transactions. Right? So you want them to execute business transactions, as opposed to having to duke it out with folks trying to grab the same data and do analysis with. So the solution that came out was this idea of a data warehouse, which becomes a central repository, a logical collection of information, you know, pulled from different sources, and really is used as the platform for um, business intelligence and doing analysis work. So, transactional information is these are the ERP systems generated through ERP systems. Analytical information is taking that same transactional data and then using another set of tools to be able to do things like product statistics, sales projections, growth trends, things of that. All right. So as we say here, the primary purpose of the data warehouse: aggregate information throughout an organization into a single repository for decision-making purposes. I mean, the good news is, or the advantages of doing this, number one is If it's done correctly, you can eliminate inconsistent data definitions. Um, you can establish and enforce data standards. Um, as a byproduct, in order to make these things work the way you want them to work, you have to work on data quality. So it requires, a focus on improving data quality. And then also it provides, timely access to needed data. So you're not necessarily having to, interrupt or deal with transaction systems, interfere with transaction systems to be able to do analysis. So this is kind of a big picture view of it. So the idea of a data warehouse is it's data from all sources. So it's not limited to just the ERP system. Obviously the ERP system, the CRM system, the SCM systems are all sources for it. But we can pull things from external information. We can pull things from things like mailing lists or stock market analysis, or we can pull information from websites, or as activities, we can pull information. All that types of information can be extracted, processed, loaded, and accessed through this data warehouse. So a data warehouse is basically it's a separate system from an ERP system, a separate database from an ERP system. And it's designed specifically to be able to load data in, bring data in, organize it, structure it, and make it available for analysis. All right. So there's a term we're using here. You'll see this ETL. And the term ETL stands for extract, transform, load. All right. Which is really the process, the steps you go through to move data from all of these different data sources to get it consistently structured and loaded into the database. So you have to extract the data from all of these different types of sources, and some of these things are different types of databases, different types of data, different types of all sorts of different things. All right. So the idea is that the ETL process, you handle the extract. The transform is really the place where you're kind of restructuring it, and turning it, restructuring it into a form that can be optimized. It's optimized for analysis. And then the load is actually the transfer of the data into the systems itself. All right. So there's got a kind of this ETL process, which is really kind of a science or an art in its own right. There's specific tools. There's a lot of tools out there that are designed to provide this kind of capability. So the other thing, just to point out on this data warehouse, if you look over here, we show like marketing inventory data. In some cases, what the organization will want to do is they'll have their data warehouse and they'll do their analysis against it. They'll go directly to the data warehouse. In other cases, what they'll want to do is actually take that information and create another smaller data warehouse, or what we call a data mart, with specific information that can be used by, say, for a department like the marketing department or the materials management organization or the finance department. Kind of a little mini data warehouse drawn from the big data warehouse. Not every organization does this. All right, so this is not an absolute hard and fast. A lot of organizations simply create a single data warehouse, and that's what they go against. Other organizations will create a data warehouse and then a set of data marts that kind of go along with, the complement. And once again, you have an ETL process, extract, transform, load process around getting the data from the data warehouse into these individual data marts. So the storage of, we talked a little bit about the storage, the efficiency of storage. Analytics data is not necessarily run in a relational database. All right. Relational databases to do types of, to do large volumes of an analytical work is not particularly efficient. So what was developed is this idea of what we call a data cube, or multi-dimensional analysis, where what you do is you store data, organize data into a structure where you can you can do very efficient analysis against it. So we call it like a cube because there's 3 dimensions to it. So there's, and the 3 dimensions can be any, you can pick the dimensions that make sense. for the example we're showing here, the three dimensions would be the store, across one dimension, the products, or maybe you start with the products. So you have the products A, B, C, D, E. You have the stores they're located in. All right. And then here we have we call promo 1, promo 2, promo 3, promo 4. This can also be a time dimension. So this is on this one, for this example, we're using promotions as kind of the third dimension, but you can also use time. So the idea of this would be, January, February, March, April, or, Monday, Tuesday, Wednesday, Thursday, Friday. All right. So this like, so you have a three dimensions, and how you would use this would be, you could come in and say, okay, what I want to do is I only want to pull the data, for across all of the stores, across all the products, but only for promo 2. All right. Or if you look at this as a time dimension, everything for the month of March. Or in another case here, what you do is, okay, all I really want to do is I want to see the three stores, all right, but I only want it for product B, and I only want it for promo, maybe two, comparing promo 2 to promo 3 for a individual product, right? So these business intelligence is kind of the BI systems, as we call them. Have been using this multi-dimensional analysis as the structure which you set up to be able to do work, basically to do um, analytical work. And the tools, a lot of these tools that are out there, will kind of set this stuff up, and this is kind of the standard that we see associated with data warehouses. So we talked a little bit about information cleansing and scrubbing. We talked about information data quality. Quality, you want stuff to be accurate. If you have inaccurate information, then the decisions you make may be flawed. All right. So the more high quality data you have in the data warehouse, then the information that you generate from it, you have a better um, better potential outcomes, or be able to make better decisions, right? More informed decisions, correct decisions. All right. So the idea is that what we call this data cleansing and scrubbing, and that takes many forms. It's kind of getting consistency of different attributes. It could be filling values in. It could be correcting incorrect address. For example, we're using an address for as an example. So some people could put a street, put like 149 Johnson Street and spell out street. Another one could be 149 Johnson ST or STR. All right. So the idea is, okay, what's consistent? Because if you want to match things up against that same address, from a computer perspective, ST is not equal to STR, which is not equal to street. All right. So achieving this stuff, getting good data, is almost impossible. All right. Trying to get data as clean as you can get is pretty pricey. I mean, this is actually a lot more difficult. One of the byproducts of ERP implementations, well, you start realizing the importance of data. All right. And the better you want the data, the more it's going to cost you. All right. So you really want to find the right balance. There's no, it's balancing it, like as we show in the chart here. We're trying to balance completeness of the data with the accuracy of the data. So most organizations, we're trying to find the ratio or the combination of completeness to accuracy. So a lot of cases, percentage, and this is not a rule of thumb. This would be kind of an example, but once again, this is a business decision, and it's driven by what specific requirements are. But like one example would be something establishing a rule of 85% accuracy and 65% completeness. But as we say, your mileage may vary depending upon the particulars of that organization. So data mining is actually not a new technology. So data mining has actually been around. It's actually has a statistical basis. All right. The difference now is the volume of data that we have to work with, and then the power of the systems to be able to compute stuff. All right. So what you can do is take these large data sets, and analyze it to extract information and kind of look for things. Some of the examples we have, there are four common analysis techniques or methods that are out there. One is, this idea of what we call predictions, the idea of kind of figuring out, what will happen, what are the probabilities of things that are going to happen in the future. Optimization, which is actually is actually been around quite some time, is this idea of, you know, trying to find the most efficient path or technique, to achieve a goal. So an example would be maximizing profit, reducing waste, and also understanding there are specific constraints that have to be identified. Okay, you only have three. Now, what is your optimal path for trucks if you only have three trucks? Things of that nature. Forecasting, kind of like predictions, but in this case, it's based on time series data. So time series data is, you know, like measurements you capture, on a week or a day or an hour or a minute. This idea of, every minute you collect a measure of something, and then what you do is you use that information and try to identify what the pattern is, and then try to get some sort of sense of what will happen in the future with that. And then finally, regression. So regression is a process for estimating relationships between variables. So the idea or the best example you would see would be Amazon, where it gathers your information about what you look at on the Amazon.com site, and then we'll go back and compare that information against other parties, and then say, what party, what books, people who buy your book, what other books do they buy? All right, and just kind of put them out there for you to evaluate. All right, so these are the four kind of core data mining analytics processes that are out there. Now, big data is, relatively recent. Probably within the past, say probably like about 10 years. Two things happening. Number one is the ability to generate larger and larger amounts of data. The introduction of the smartphone. Everybody has a computer that can generate data in their pocket and can communicate across the internet. Generates large amounts of data. The ability to store that is, capture it, generate it, capture it, store it, and then analyze it is kind of what big data is all about. And traditional relational databases are not necessarily have trouble. You get to a certain point. I mean, so it can deal with millions and millions of rows, but a lot of the stuff we're seeing now is now measured in billions and billions. All right. So traditional database approaches really have some problems. So a lot of what you've seen is kind of a new set of tools, new set of technologies that are designed specifically for these large, complex data sets of how to manage them. The four attributes, the four focuses, which are challenges we deal with big data. Number one is the variety of data. So you've got, not only structured data, you've got unstructured data, all sorts of different kinds of things coming in that has to be dealt with. The veracity of the data, which is the truthfulness of the data. How accurate is it? Is it high quality? The volume of the data. We talked about this a little bit. The pure volume of the data. Now you said moving from millions to billions is kind of what that's all about. So now dealing with a much larger scale, and then the velocity of data. We can generate, data now in large volumes, but we can also generate large volumes quickly. So the numbers that we see now, flowing across the internet of, imagine everybody, going to Amazon.com on Black Monday, You think about the volumes associated with that. Those are some very, very big numbers. And then finally, one of the things we look at with, part of what we try to do with data is be able to tell a story with it, be able to communicate with it. And that can be a challenge because, a lot of times you just kind of throw numbers up and all you see are numbers. And really what the goal and objective is trying to come up with an approach to communicate something, using not necessarily using words or just numbers, but through pictures. All right, so this idea of what we call data visualization. So here's just a couple of examples of visualizations. Graphs, which have, kind of really came into, that was one of the things that we really saw introduced with the first generation PCs, a spreadsheet. You can put a bunch of numbers in and you can generate graphs very easily. So that's been in spreadsheets for a while, but now we're seeing more sophisticated types of presentations, not just simply graphs, but we're seeing things like, for example, um, maps, with color coding, and with shading to be able to, be able to tell a story. So the idea is of what you want to do is kind of use different colors to designate different things and be able to look at it by, an observer by looking at um, the pictures, the infographics or the visualizations that we put out there, be able to look at it and be able to tell a story without necessarily having to see all the details. So this becomes, kind of when we talk around dashboards and, presentations and things like that, this actually becomes a um, pretty important thing to do. And it's not necessarily a trivial thing either. Trying to make effective visualizations can be a pretty tough job sometimes, but it's an area of expertise and something you'd want to be able to focus on. Okay, so that is it for chapter 6.